we want to take a couple moments. We've learned a little bit about oxidation reduction reactions, and now we want to actually look at how we assign oxidation states. Now, you notice here at the top of the page, top of the slide, I say you must memorize these things. That is not a joke. You really do need to memorize these because they will not be given to you on tests, quizzes, or any other materials. And I'm going to go ahead and change my color just because, hey, I feel like this is a good time for me to do so. Now, just to review the rules, oxidation state for any atom of an element, meaning if it's just by itself, regular as it's going to be 0. Meaning if I have a copper atom, it's going to be 0. If I have one of our diatomics, also, that means it's going to be 0. So F2, N2, just review that part. Start at 7, make a 7, add hydrogen. Oxidation state for a monatomic ion or a regular ion, non-polyatomic, is just going to be the charge on that ion. Oxidation state for oxygen is always going to be -2, unless it's in a peroxide where it's -1. Hydrogen +1 in covalent bonds. Fluorine -1 in compounds. The sum of the oxidation states total needs to be 0, and sum of oxidation states equals the charge of the ions in ions. And that part, don't worry about so much. We'll come back to that at the end. Now, we're going to go ahead and jump ahead to a slide where we got some practice with actual compounds. Because if you can do this in a compound, you can do it in the reaction. So, you're given the compound magnesium bromide. What will be the oxidation state? Again, remember, the sum of the oxidation states needs to equal out to 0. So, let's take a look at what we have here. I have magnesium and bromine. Well, bromine, if I'm looking at this as an ionic compound, so that means the magnesium is going to have an oxidation state of +2. And my bromine is going to have that of -1. Now, since I have 2 bromine, 2 times my -1 gives me my overall charge that I need of 0. So that works out well for us. Now, this last box is here is just empty because I don't have a third element for these first couple. So don't think that that's what these mean down here. Now, let's look at the next example. I have iron 3 oxide. Well, let's take a look and see what it is that we're dealing with. Oxygen, we know that the oxidation state is always going to be -2. So, if I have 3 of them, that means that my overall charge on that side is -6. Or overall oxidation state on that is -6. So, that means each of my iron is going to need to be +3. Now, of course, this was already given to us knowing the name and the formula, but just in case, you always want to keep in mind. Let's look at another example. Now I have a phosphate ion. Notice that it has a charge of -3, so that means I'm going to end up with 3 more electrons, or 3 more in the oxidation states than I would have for the other. So, let's look at it. I have oxygen again is -2. So if oxygen is -2, -2 times 4 gives me -8. I need to be able to have 3 electrons left. So that means that my phosphorus has to have a oxidation state of +5. Now, under normal circumstances, when we look at it, we would think it would be negative. But I want to keep in mind exactly what we're dealing with here, and that we're looking at how can we get to have this volume, or not volume, this charge on the ion available. For aluminum nitride, we have +3, normal oxidation states for each of them, -3. Not too much of a problem. What about for our sulfur trioxide? -2. So if we have -2 and we have 3 of them, that gives us -6. We only have 1 sulfur, +6. Now, I'm going to go ahead and jump down here because I want to leave this example and this example for you. I'm going to put a star next to it. I want you to practice those two. Now for our, sorry, this is hypochlorite? Hypochlorous acid, sorry. So we know that our oxygen is still going to be -2. That part's not going to change. And we have to look at how the other ones are actually going to fare in to block this off or to even it out. So if we have 2 of our -2s, that means we have -4. And we know that hydrogen is only going to be +1. according to our oxidation rules. So plus 1, that means we have to have plus 3 left over. So in the case of what we're doing here, our oxidation state for our chlorine is actually going to be plus 3. So again, make sure you're going back to the rules, because the oxygen many times, if there's oxygen involved, is going to help you to understand what the relationship of the other ones is going to be. Now, moving along into the next step, we want to look at reducing agent versus oxidizing agent. The reason why we want to pay attention to this is because, one, it's going to show up on your test, but two, it helps you to understand why certain things happen. Now, something that I like to remember is the reducing agent, this thing right here, is going to be the thing that is oxidized. So it's sort of a game of opposites. Whereas the oxidizing agent is what is reduced. Now, as a quick review, when something is oxidized, what happens? Remember, Leo the line goes Girth, so lose electrons oxidized and gain electrons reduced. So let's look at our example. We have magnesium starts off as 0, our copper chloride, -1, +2. Okay? On this side, our magnesium has a charge of, or an oxidation state of +2, still -1 here, and now this is 0. So we need to focus on what two things. Let's change the color. Let's go back to my red for now. In terms of what was oxidized or what lost electrons, well, that will be our magnesium. So I'm going to draw the tie lines that go all the way over here. What gained electrons? That's going to be our chlorine, or our copper, sorry. So in the case of what we're dealing with, the chlorine is sort of like a spectator. It's just there. But let's take a look at what we have. Since our magnesium lost electrons, it was oxidized, making it our reducing agent. And since our copper actually gained electrons, which took it from +2 to 0, it is our oxidizing agent. Now, many times we can tell this if we just look at the information that's given to us. If I gave you the ion, aluminum 3+, and asked you, is it going to be a reducing agent or an oxidizing agent? The goal is to get it from +3 in this ion state to a regular atom, or into a 0 state, basically. So that means it's going to need to gain electrons, meaning it's going to be reduced. That would make it an oxidizing agent. What if I had just plain magnesium? Oh, nope, I don't want to use that. We've already used that one here. So let's erase that. What if I used instead calcium? Most likely I'm going to be trying to strip electrons away or get it to lose electrons. So if it loses electrons, it's being oxidized. That's going to make it our reducing agent. Now, you're going to have a little bit more practice with this in class. Don't stress over it. It's not anything too crazy to remember. Just remember it's the opposites. So the reducing agent is oxidized, and the oxidizing agent is reduced. Well, that's where we're going to end this video for now. Have a great evening, and I look forward to seeing you in class.